Yeah. Okay. In the last class, we completed about electrostatic, and also I given some questions to you. Now today we'll do current electricity topic. Understand?
Okay,
So
sir.
I'll start that. Yeah, actually, it is. We are talking about electricity. Understand? Electricity. In that electricity have two parts. One is electrostatic, one is electro or current electricity. Current electricity. Current electricity and electrostatics. Everything, if you see all the things, all the branches of these, they are talking about charges. Understand? If you see all the branches, they are talking about what? Charges. Here electrostatic means study about charges when they are at rest position. Current electricity means study about charges when they are in motion. Even though are in motion, even though are in at rest, the complete discussion about what? Charges and its properties. Now till the last class, we discussed that electrostatics. In that electrostatics, we have been completed the Coulomb's law and what are the properties of charges, what is the force between the charges, what is the force between what is the force between same charges, unlike charges, like charges, and also we discussed given a formula for force between the charges. These things we discussed. But now today we are going to explain about current electricity, that is a part of the electricity branch. It is deals with the motion of the charges when they are in motion. Understand? So that is the topic today. So now I'll start the topic now. So the topic now first one is electrostatics. No, sorry, we are talking about electricity, current electricity kada? Current electricity. Current electricity. So, what is current electricity? Write down the statement. The study about charges, the study about charges which are in motion, which are in motion. The study about charges which are in motion is known as current electricity. Now let us assume that this is a conductor. This is a conductor. When this is a conductor, if you have not connected the conductor to the any source of power, you have not connected you have not connected any source to this conductor. So what going to be happen inside the conductor? Generally, charges will takes place. Understand? Inside the conductor, charges are moving in random direction. So the conductor having negative charges, the negative charges are moving in random direction when we not connected any source to the conductor. But as you connected in this case, if you observe any cross section area, when they are not connected any source to the conductor, if you observe any cross sectional area of the conductor, across the cross section, left side charges motion, right side charges motion are approximately equal. When left direction motion, right direction motion, because of the randomness of the charges, you cannot get any net charge through the cross section. You can't observe any net charge flow through the cross section because the left direction charge motion, right side charge motion approximately equal because of the randomness. So you cannot find any charge flow through the cross section area. Okay, so because of the no connection, no power source. But if I connect the power source, what is the power source here? The power source is nothing but battery, cell, okay, our power supply is all the power sources. When you connect the power source to the conductor, now you will observe the charges motion now not only in one direction. The charges cannot move random direction. When you are not connected the source, the charges move inside the conductor in random way. But when you connect the source, the charges will move in a particular direction, that is called ordered motion. Because of the ordered motion, you will observe something net charge. Here net charge cannot become zero across the cross section. Across the cross section you cannot observe any, you will observe some net charge. It can't be zero, because the source is move all the charges in one direction. The one direction motion is known as ordered motion. In the ordered motion, if you observe any cross section area, the net charge can't become zero. So the net charge per unit time. So here, what is the definition? The net charge per unit time is known as current. The net charge per unit flow is known as current. Current is indicating with letter I, and that is equal to charge per time. Here charge is nothing but net charge through the cross section area in a unit time is given as current, electric current. So units for the electric current is coulomb per second. This coulomb per second also called ampere. Coulomb per second also called ampere. Understand? So this is the formula for what? This is the formula for current flow in the conductor. The charge per unit time is known as current. Understand? When you will observe this current, you observe the current when you connect the power source to the ends of the conductor. When you connect the power source to the ends of the conductor, all the charges inside the conductor will move in one direction. Now, if you observe any cross-section area of the conductor, you will have some net charge. The net charge per unit time is known as electric current. Units are ampere. But if you not connected any source, charges move in the random direction. When the charges are moving in the random direction, what going to be happen? How many charges are moving left direction? Same number of charges will move right direction. So net charge becomes zero. When net charge becomes zero, there is no current supply. There is no current flow in the conductor. That is the difference between when you connect the power supply, when you not connect the power supply, having the current. Okay. Now we'll do one problem based on here. I'll give one problem to you. The problem is example question. So this is a conductor. In this conductor, a 10 coulomb charge is moving. 10 coulomb charge. When you connect the source or battery to the conductor, how many coulomb charges are passing? 10 coulomb charges are flowing for 1 minute. In 1 minute, how many coulomb charges are passing? 10 coulomb charges are passing through this cross section area. Because of this power supply, through this cross section area, 10 coulomb charges flowing in 1 minute. Now what is the current flow in the conductor? What is the current flow in the conductor? That is a question. So how do you solve this question? They given the charge and they given the time, and they are asking to find
Sir,
current.
10, why 1, sir?
Yeah, look at here. Here charge. How much is the charge flow? Charge flow is 10 coulomb. Charge represented with letter Q, and coulomb is the units for the charge, that is 10 coulomb. And next time taken for traveling this 10 coulomb is 1 minute. 1 minute is equal to how many seconds here? 60 seconds. Understand? 60 seconds. Now the current formula is, tell me the current formula. Current formula. Tell me. Current formula is charge, net charge flow per unit time. So current is equal to 10 by 60. So 0 gets cancelled. Then current is equal to 1 by 6 ampere. So this is the value of current flow through the conductor. Understand, Chaitanya?
Yes, sir.
Next, this is another problem I will give. Can I give one more problem?
Yes, sir.
Now one more example problem. See here. Now this is a conductor. Through this conductor, 2 ampere current is flowing. 2 ampere current is flowing for 10 minutes. For 10 minutes.
Sir, about the diagram is not visible, sir.
Okay. This is a conductor. Through this conductor, how many ampere is flowing? 2 ampere is flowing for 10 minutes. For 10 minutes, how much current flow? 10 ampere current, 2 ampere in 10 minutes. Tell me the charge flow in the conductor. Amount of charge flow in the conductor. Amount of charge flow in the conductor. Tell the answer. Amount of current, amount of charge through the conductor. What is the formula? Data, first write down the data. They given current value. How much? 2 ampere. They given time also. How much? 10 minutes. Convert into seconds. That is 600 seconds. And they're asking to find a charge. So which formula is relating these are all the things? That is I is equal to Q by T. From here Q is equal to I into T. I value is 2 and time value is 600 seconds. So totally how much is the charge here? Charge is 1200 coulomb charge. 1200 coulomb charge is flowing. 1200 coulomb charge is flowing. Understand?
Yes, sir.
Can I give one more question?
Okay, sir.
One more example question I will give. There is a one more conductor. There is a one more conductor. 3 ampere flowing. 3 ampere flowing through the conductor. In this, when it is 3 ampere, the charge will be 1200 coulomb. When 3 ampere current flows, the charge flowing how much? 1200. Then time for flowing this 1200 coulomb when it is a 3 ampere. Tell me, what is the formula again? First of all, write on the data. Current they given 3 ampere. Charge they given 1200 coulomb. And they are asking to find a time value for traveling, passing for this 1200 coulomb from the conductor. So that is I is equal to Q by T. I is equal to they are asking to find time kada. So time is equal to Q by I. The Q value is 1200.
100 and I value is 3, sir.
Not time. I value is 3. 3 ones are 3, 400s are. So which means 400 seconds time have been taken for traveling for 3 ampere through the current, through the speed of 3 ampere, 1200 coulomb.
Okay, sir.
Next, simple circuit. Next one is what? Keep a side heading. simple circuit. Simple electric circuit. Simple electric circuit. What is this simple electric circuit? So write down simple electric circuit or simple electric circuit is the circuit showing the electrical components with symbol. Understand? Simple electric circuit is a circuit showing electrical components with symbol, and it shows the connectivity. It shows the connectivity between the components. It shows the connectivity between the components. This is your what? Electrical circuit. Understand? Now,
Yes, sir.
first of all, to show the electrical components, electrical circuit, so what supposed to know? First you know to know the components of the symbol, electrical components and its symbols. Understand? To draw the simple circuit or circuit diagram, circuit for electrical circuit, you should know electrical components as well as the symbols of electrical components, such that you can draw a simple circuit diagram for given components. Now let us first of all know the components and their symbols. Okay na?
Okay, sir.
Now symbols, components and symbols. Components, what components? Electrical components and symbols.
Sir, textbook page number 169, they gave, sir.
They given. Can you tell me what is the first component?
Sir, cell, sir.
Cell. How do you show the cell here? Look at here. You can show the cell with a parallel lines, but one is small, one is big. The small one is indicating the positive terminal. Big one is representing positive terminal. Small one represent negative terminal. So write down the name of the component, cell. The symbol for the cell is what? This is the symbol for the cell. This is positive. This is the negative. And next, tell me what is the next component? Next component.
The next component is connecting wires.
Connecting wire. Just you can show this connecting wire in a simple manner. This way. Simply you can take a bold line. Connecting wire. Next, can you tell me what is that?
The next one is cells in series.
Cells in series.
Yes, sir.
They are asking to say cells in series. So this is let me take two cells. Cells in series means negative terminal of the cell is connected to positive terminal. So such a way that many cells are grouped, that is called actually grouping of the cells. Even we learn that grouping of the cells in head classes. Okay, so this is a connection of the cell. Actually, cells in series kada. Component name is cells in series. Cells in series. The symbol form is, this is the symbol form. So this is a symbol form. Likewise, you can connect many number of cells. So they actually cells in series. The situation is known as actually battery. We call it as a battery. Next, can you tell me what is the other component? What is the name of the other component?
Sir, already said next one.
Amma? Bulb.
Yes, sir.
Next to bulb, component name is what? Bulb. The symbol for bulb is this is a symbol for the bulb. And next component, tell me.
Sir, next one fuse.
Fuse. So fuse, the fuse is represented with this symbol. Understand? Next,
Yes, sir.
next,
Sir, next one ammeter.
ammeter. Ammeter. What is this ammeter? Ammeter. What is this ammeter? Ammeter is a device actually. It is used to measure the current flow through the conductor. Understand?
Okay, sir.
Ammeter is a device. Here I will tell one by one what is the uses of the components and what is this priority in the circuit diagrams I will say now. So here cell is act like a power source. Understand? Cell is act like a power source for the network, and wires, these are the wires are used to connect the components, electrical components. Okay, these are the wires used. And next, cells in series. The cells in series also utilized as a power source. Understand? Next, bulb. Bulb is a component, electrical component which give the light to the surroundings. Next, fuse. Fuse is a device. It is used to what safety precautions in the safety measurements, or else to overcome the overload situation. Will use this fuse. Next, ammeter. What is the ammeter? Ammeter is a device used to measure the electric current through the conductor. And next, what is the next given component? Chaitanya, what is the next component? Chaitanya, are you there? What is the next component? Fuse, bulb, even voltmeter also present. Voltmeter, not voltameter, it is a voltmeter. The voltmeter also it is an instrument to measure the potential difference. Bulb, symbol, connecting wire, even one more also present, key.
Yes, sir.
Key.
The key and back, sir.
Key symbol is this is a key. Actually, this is called top key.
Back.
Next, plug key. Plug
Sir,
key.
even fixed resistance and variable resistance
Resistance.
and resistance.
Resistance symbol is this is the resistance symbol. This is a fixed resistor. Fixed resistance and variable resistance. Variable resistance symbol is similar, but this is the how the variable resistance. Understand?
That cells in parallel and rheostat also there is.
Okay, this is a rheostat or variable resistance you can take, and cells in parallel are cells in parallel. Cells in parallel are so same cells. Let us take 3 cells here. 3 cells. All the positive terminals are connected one position. All the negative terminals are connected in other position. That is called parallel grouping of the cells. So these are the cells. These are the some symbols to represent any circuit diagram. Now, by using these cells, I construct a simple network, a simple circuit. Can I construct a simple circuit? Yeah, I'll now construct a simple circuit. So you look at here, simple circuit now. Simple circuit. So simple circuit, this is a connecting wire. For the connecting wire, I connected a bulb, and this bulb is connected with the key. This is a key, and again connecting wire. These connecting wires are connected to source. This is a source, and this is the way we have circuit. Now here the circuit have two types: open circuit and closed circuit. Okay, this simple circuit has two types: open circuit and closed circuit. So let us discuss first open circuit. Open circuit. What is this open circuit? So in the simple circuit, this is the bulb, this is the key, and this is the power supply. Okay, power supply, bulb, key. Now look at here. If the circuit is not closed, when circuit is not closed, you cannot observe any current flow in the circuit. So the situation is known as what? That situation is known as open circuit. So this name is not appearing. Open circuit. Open circuit is the circuit no current flow, no current flow in the circuit. Is known as open circuit. Means is the circuit current flow is not, no current flow in the circuit is known as open circuit. Open circuit. Through the appliances, no current we cannot observe, and it is happened when the switch is open, when the switch is not closed. It is happened when the switch is not on. Actually, this is open circuit. When we will get, when the switch is not on, the no current observed in the circuit. The no current observed in the circuit is known as open circuit. Next, similar way, closed circuit. Closed circuit. So what is a closed circuit? It is the circuit will observe current through the appliance, will observe current through the appliance. In that case, it is happened will observe current through the appliance. It is happened when switch is closed. When switch is closed or on. When switch is on, then the current we can observe in the appliances, that circuit is known as a closed circuit. Even the closed circuit or open circuit will show with a symbol form. Now here, this is an example for what? Closed circuit. Because you cannot observe any current flow, because you have, this is a symbol of key. The key is open. When the key is open, through this current, through this bulb, the appliance, through this appliance, current will not flow. So that this is an example for what? Closed circuit. So open circuit. This is not closed. This is open circuit. Because switch is open, no current we are observing. When no current is observing, that open circuit. Next, what is the symbol for the closed circuit? The symbol for the closed circuit, this is the appliance, this is the bulb, this is connecting wire, this is a switch, and this is a battery, and this is a where the connection is happened. Now here, if this key is closed, current starts flowing from the battery. That current passes through the appliance, then the bulb will glow. So such way, the open circuits are present. Understand? Got it?
Yes, sir.
Yeah. Next, is there any questions here?
No, sir.
Next one. Cells in parallel, cells in series. Grouping of the cells. Next one is what? Grouping of the cells. Grouping of the cell. We have grouping of the cells. We have three types of grouping. First one is three types of grouping. We have three types of grouping. Three types of grouping. The very first one is series grouping, means series connection of the cells. Second one is parallel grouping. Parallel grouping means parallel connection of the cells. Next one is mixed grouping. Mixed grouping. Series connection, series grouping, parallel grouping, and mixed grouping. These are the three types of grouping we have. Understand? Let's see first series grouping. Let us see the series grouping. Series grouping. Series grouping. So for that, I will take three cells here. This is first cell. This is first cell. This is second cell. This is third cell. So here, this is the positive terminal, and this is the negative terminal of the first cell. The positive terminal, negative terminal, positive terminal, negative terminal. This is the way three cells we have. Here, when you are connecting the series connection, first battery or first cell negative terminal is connected to second cell positive terminal. And same way, second cell negative terminal is connected to third cell first terminal and positive terminal. So this is the way the connection takes place. So this connection is known as series connection or series grouping of the cells. Now, when you connect this way, what is the use? What is the help of these connections? If you connect these batteries or cells in a series way, the first cell having EMF E1, second cell having EMF E2, the third cell having EMF E3. So each cell having one particular EMF value. But you connect it as a series connection, you will get effective EMF. The effective EMF of this grouping of the cells is nothing but E1 plus E2 plus E3, which means that you will get sum of the EMFs. When you are grouping these cells in a series way, you will have sum of these groupings, sum of the EMF of the grouping, which means that you will get more potential value when you have the series connection for the batteries. So this is a cells connected in series. And for today, I will stop the session. In the coming class, I will explain parallel grouping and mixed grouping and remaining concepts also. For today, we will stop the session. Bye.